Hi everyone, this video is for our topic of velocity. On the screen you can see the learning targets, recall the definition of velocity, compare velocity and speed, execute calculations for velocity, and some of the advanced things I might be looking for are interpreting the slope of a position time graph, and maybe even creating a velocity time graph given a position time graph. Alright, so let's talk about what is velocity. Velocity is the change in position of an object divided by the time of travel. So we've already talked about how displacement is the change in position. If you take that change in position and you divide it by time, that's what velocity is. So in other words, velocity is displacement divided by time. And so if you think about velocity is really like how fast something is going. Well, for us to measure how fast something is going, we have to know how far it went and how long it took. And we compare those two things. That's exactly what we're saying here. Velocity is displacement divided by time. How far did you go divided by how long it took you. And so velocity is how fast something is moving in a certain direction. You can think of many examples. A car, a football player running down the field and getting a 40 time, a track runner running 100 meters and seeing how fast they can do it. But we all can kind of have a general idea of like what velocity is and what does it mean to be fast. Velocity is not the same thing as speed. Speed is not a vector quantity. It doesn't have a direction. Velocity does. So just like when we talked about displacement and how you could have negative displacement, and you can move in the negative direction because you're moving to the left, velocity is the same. If you are moving to the left, then you might have a negative velocity. And so that's what this picture right here is showing, that this car has a negative velocity. Speed is just like distance. There is no positive and negatives. But velocity, you have to be clear about which direction you're going. And sometimes we say the direction by putting a negative symbol. And velocity and speed have many measures. We'll be using mostly meters per second. That's the most common term used in physics. You might see kilometers per hour. Every now and then we might reference miles per hour because that's what many of us are used to. But in general, the physics community uses meters per second. So velocity is a vector. It can be drawn as a vector, which is a line with an arrow, and it has a direction. So if I were just to kind of give a few examples, remember a vector is just a line with an arrow. So if I had an object moving at 5 meters per second, I could write 5. I could even be clear about the units here, and I could say 5 meters per second. All right, and this one is going to the right. If I wanted to draw a velocity vector that was 10 meters to the 10 meters per second, I would try to make it, twice as big, trying to keep my vectors scaled correctly. And then I could put like a 10 meters per second on this arrow. All right, but velocity is a vector, so you have to be clear about what direction you're moving. And a vector can be drawn as an arrow in a certain direction. All right, so a couple of examples. A person walks 3 meters to the right in 2 seconds. What is their velocity? All right, so I'm just going to write down a few things here. Again, when we solve problems in my class, there's a certain method I want you to follow. We're going to read it again. We're going to underline some of our numbers here. So 3 meters to the right, that's important, in 2 seconds. All right, so that means I know my displacement. Remember, we write displacement as a triangle with an x, which means change in position, and that's going to be 3. And then I know that my time is 2 seconds. Sometimes we might even say that our change in time is 2 seconds. How much time has passed? So we will also put a triangle to represent the change in time. How much has the time changed? In this case, it's 2 seconds. All right, now we need a way to relate these two things because I'm trying to find velocity. And so the question is asking for velocity. There must be some equation that I can use for velocity. And sure enough, there is. Like I said before, velocity is displacement divided by time. I have displacement and I have time. And so this is the equation that we can use for velocity. V for velocity is equal to your final position minus your initial position divided by time. Or another way to say that is displacement divided by time. That's what velocity is. So for this example, I'm just going to plug in my numbers to this equation. I have 3. I just realized I made a mistake. This isn't supposed to be seconds. This is 3 meters. Bonus points for anyone who caught that mistake. So 3 meters divided by 2 seconds. And that is going to be equal to 1.5 meters per second. And so you might see that my units for velocity are meters per second. I hope that makes sense when we look at what we just did here, because we have meters divided by seconds. And now on this side, I have 1.5 meters over seconds. So that's exactly how we get meters per second for velocity. It's from our units of displacement divided by our units of time. All right, here's another example. A cart has an initial position of 2 meters on a track. The cart is pushed to the left and travels for 0.8 seconds until it is stopped at a final position of 0.4 meters. What is the cart's velocity? All right, so again, I have this equation. I'm going to use that in a minute. Let me just make sure I write down a few things. So I want to underline my numbers. So I have an initial position, a final position. All right. So what do I know? Well, my initial position was 2 meters. So I'm going to put xi equals 2.0 meters. So again, if we're thinking about, where exactly is it? Its final position is 0.4 meters. And that's interesting. That is a smaller number than my initial position. For that to happen, I must have been moving to the left, and that's what it says. The cart is pushed to the left. So we should be kind of looking out for, a negative number here because it seems like we're moving to the left. That's what the problem says. All right, and my time is 0.8 seconds. If I can write 8, this little tool. Okay. So now I have my knowns. I don't know velocity. I'm trying to figure out what is velocity. All right, but I have an equation right here that kind of relates those things, especially this part right here. I have final minus initial divided by my change in time. Again, notice that this part of the equation is just exactly what we did on our first lesson, which was displacement. And now we're just taking that and we're dividing it by time to get our velocity. So we're going to do 2.0 minus 0. Ooh, nope, just kidding. I don't want to erase that. So let's just cross that out. And I hope, again, some of you might have noticed my mistake there. 0.4 is my final position. And I think I might have caught that because I wrote out my numbers. So that's a really good example of why we write out our numbers. Keep track of which numbers are which, because if you don't, you can make a silly mistake like that. I caught myself, and now I'm on the right path. All right, 0.4 minus 2.0, that's negative 1.6. That divided by 0.8, put a little 0 here so we all know what we're talking about. Okay, and that's going to be negative 2 meters per second. So again, I'm moving to the left, so having a negative velocity makes sense. Again, check your work, but that number makes sense to me. All right, if you want to move on to the actual practice problems, I think now might be a good time to do that. But I'm going to give you, anyone who's looking for a more advanced understanding, I'm going to give you guys the 2 more things to think about. So here's a pretty tough one. A baseball pitcher throws a baseball 60 feet, which is about 18 meters, to home plate at a velocity of 90 miles per hour, which is about 40 meters per second. How long does it take for the ball to reach home plate? Okay. This one is tricky because we're not trying to find velocity. So let's write out a few things. Well, first we're going to underline what we know. So I'm seeing 90 miles per hour. I'm going to usually use 40 meters per second. So let me underline that one. That's probably the one I want. And it's asking for how long does it take. So it's asking for time. All right, I know I'm going to use this equation. Let me write out what I know. I know my displacement. I know my displacement is 18. I know my velocity in this case. I know velocity. And that's a little bit different here. And now I'm going to have to do a little bit of work to figure out something else. It's asking for time, so I want to know time. All right, let's see. So equals what? Okay. All right, this is in meters. This is in meters per second. All right, so I'm going to use this equation where velocity is equal to displacement divided by my change in time. All right, so now I'm going to go with 40 as my velocity. That's what I was given. Equals, let's see, 18 divided by my change in time. All right, you might have to do a little bit of manipulating of this equation, but basically if we rearrange this, we can multiply both sides of the equation by this change in time. So I multiply this side of the equation by change in time. I multiply this side of the equation by the change in time. And so these will cancel out. Now what I end up with is 40 times the change in time equals 18. And now I need to divide both sides of the equation by 40. If I divide both sides by 40, I'm going to end up with my change in time. All right, 40 divided by 40, that cancels out. My change in time is going to be 18 divided by 40. I'm not sure what that is off the top of my head. I think it's about 0.45 seconds. And that makes sense. If you've ever seen a baseball game, you know the batter doesn't really have a lot of time to make a decision on whether or not they're going to swing the bat or not. All right. It definitely doesn't take more than a second for the ball to get from the pitcher to home. So this time being less than 1 second, that makes a lot of sense to me. All right. I hope this was useful. You have a few practice problems to do, so good luck with that.